Hello, this video is for Mrs. Rose's AB Calculus class on the fundamental theorem of calculus. Alright, the fundamental theorem of calculus is pretty important. In fact, you could say it's fundamental. We've got a couple conditions. If a function, f of x, is continuous over some interval from a to b, and capital F of x is the antiderivative of f of x on that same interval, then we can say that the integral from a to b on that interval of f of x dx is the antiderivative, capital F of x, evaluated at x equals b and x equals a. That line with these x values means evaluate your antiderivative at x equals b and x equals a. To get the area, which is what a definite integral is, to get the area under a curve, or between the curve and the x-axis, we're going to do f of b minus f of a, and that equals the area between f of x and the x-axis on the interval from a to b. So, for example, we've got this quadratic, and we want to find the area of the shaded region. Previously, we could only find definite integrals of shapes that had geometric regions, semicircles, rectangles, triangles, etc. Now we can find the area from 0 to 4 of this quadratic. So we've got the integral from 0 to 4, and then this equation is the integral of negative x times x minus 4. It's negative because the quadratic's upside down, and then we have a root, a 0 at 0, and another 0 at 4. I'm going to multiply that out to negative x squared plus 4x, and now we want the antiderivative. So this equals negative 1/3 x cubed, add 1 to the x squared, and we divide by the reciprocal, the new exponent, plus 2x squared, add 1 to the exponent, divide the coefficient by the new exponent, and we're evaluating at 4 and 0. So this equals negative 1/3 times 4 cubed plus 2 times 4 squared minus the antiderivative evaluated at 0, and that equals 4 cubed is 64, divided by 3, and then 2 squared is 16, times 2 is 32, minus 0, and then make a common denominator, and then subtract, and 32/3 equals the area of the shaded region between the quadratic and the x-axis. And now let's try another example. Okay, the integral from 2 to 5 of x cubed minus 3. The first thing we need to do is find the antiderivative. Again, we're adding 1 to the exponent and dividing by the new the coefficient divided by the new exponent. Okay, we are going to evaluate at 5 first, and then at 2. 5 to the 4th power is 625. Divided by 4, minus 15, minus 16 divided by 4, minus 6. And our final answer is 573 divided by 4. This number represents the area under x cubed minus 3 on the interval from 2 to 5. Alright, so for some practice, if you want to try solving each of these definite integrals and then put the order from least to greatest, I'm going to pause and try these here, and I'm going to show you the answers in just a moment. So here are the answers from least to greatest, and it's up to you to figure out which answer goes with which definite integral. Alright, the mean value theorem for integrals states if f of x is continuous on the interval from a to b, then there exists a number c in the interval from a to b such that there has to be a rectangle whose area is precisely equal to the area of the region under the curve. So the rectangle would be width and height. B minus a is your interval. Of your shaded region, and f of c is your average y value of the function on the interval from a to b. Quite frequently, the average y value is what we're solving for, so if you divide both sides by b minus a, that's fairly typical. So when you integrate the integral, this is the antiderivative evaluated b minus the antiderivative evaluated a over b minus a. And this one should look familiar. It is the average rate of change formula for the antiderivative. So one of the things that you'll be asked to do is to find the average value of a given function over a given interval, and we're using the average value of a function formula. Previously I just had the b minus a underneath the integral, but frequently we just have it as a fraction on the outside. So for number 1, f of c is going to equal 1 over 4 minus 1 times the integral from 1 to 4 of 3x squared minus 2x dx. From this point we're going to take the antiderivative, and the fraction. So the antiderivative of 3x squared, add 1 to the exponent, divide the coefficient by the new exponent. Both of these, we're going to get x cubed minus x squared, and we're evaluating at 4 and 1. Evaluated at 4, we've got 1/3 times 4 cubed minus 4 squared minus 1 cubed minus 1 squared, and that ends up being 1/3 times 64 minus 16 minus 1 minus 1, which is 1/3 of 48, which is 16. 48 represents the area under 3x squared minus 2x from 1 to 4. 16 represents the average value of this function on this interval. For the second one, we're using the same formula. F of c equals 1 over 2 minus negative 2 on the interval times the integral of 4 minus x squared dx. Okay, so we have 1/4. And then we want to take the antiderivative and then evaluate it at 2 and negative 2. So this equals 1/4 times 4 times 2 minus 1/3 times 2 cubed minus 4 times negative 2 minus 1/3 times negative 2 cubed, which equals 1/4 times 8 minus 8/3 minus negative 8 plus 8/3, which ends up being 8/3. Again, 32 over 3, that represents the area underneath 4 minus x squared on the interval. 8/3 represents the average value of the function on this interval. Here are 2 more examples. If you want to pause this and try it yourself, go ahead. And here are the answers. Alright, now let's try a graphical approach. Okay, so we're given this function f of x, and we want to find the average value of x on the interval from negative 8 to 5. So we're going to write f of c equals 1 over 5 minus negative 8 times the integral of f of x dx. So this is 1/13, but this we can find using geometric area. So here, I've broken up into different pieces. This is the area of 2, area of 3, area of 2, area of negative 2 pi. It's negative because it's below the x-axis. Area of 3, area of 6, and area of 3. So this equals 1/13 times 2 plus 3 plus 2 minus 2 pi plus 12. I wouldn't actually plug this into the calculator. I would just leave your average value answer either in this format or this format. Try this one. And here is the answer. That's it for this video. Good luck on your homework, and I hope you have a wonderful afternoon. If you have any questions, please see me in morning, send me an email, or see me after school.